Hi there, I'm Janet Cotton, the Managing Director of 180 Materials Testing, an ISO 17025 accredited lab and the most widely scoped lab in Africa. Today I'm going to talk to you about the importance of proper machining of mechanical test samples. I have here two tensile test specimens, or examples of tensile test specimens. Now, in order for the results of this test to be valid, so in other words, when you measure the UTS, the ultimate tensile strength, the yield strength, and the elongation to failure, in order for those results to be valid and reliable, which are structural properties of the material, the sample has to be tested according to the valid ASTM standard. And part of the ASTM standard deals with how the sample should be machined. So this reduced section over here needs to be machined in a particular way so that both sides of the sample are completely parallel without any error. The radii have to also be machined in to a very tight tolerance. There should be no undercuts as you machine the reduced section from the clamping section. There should be no undercuts in the radius. And the surface finish needs to be at least 2 micron or better. If the sample is not machined with this attention to detail, the test results that are generated are not valid and cannot be used in practice. Likewise, the dimensional tolerances for the Sharpie impact tests, I have a set of 3 here with me, have to be machined to a tolerance of 0.01 millimeters on all dimensions. And the surface finish needs to be at least 2 micron on all 4 sides. If this is not achieved, the impact test could fail prematurely, in other words, at a lower impact energy, and that would basically mean that a possible welding procedure that could have passed the impact tests would then fail due to improper machining. And we all know that we don't want our weld procedure qualification records to fail. I have here an example of a bend test. This is a sample that's already been bent on the bend testing machine. And this sample also needs to be very carefully machined. What we see sometimes in the industry is that these samples are just simply cut on a bandsaw and not machined down to the tolerances and the surface finishes required. So if you have a look over here, the purpose of this test is to evaluate the welded joint that you see over there. If the sample is not machined to the correct surface finish, it will be impossible to detect any flaws in the welded joint after the bend test is completed. And that can mean that if the surface finish is not appropriate, that a welding procedure qualification could pass when in fact it should have failed. And that will mean only catastrophic results if the welding is conducted according to a weld procedure that should have not passed.